Hi, and welcome to this tutorial video on the Dagger scoring system. In this video, we hope to better explain the type of scoring that is used in the Dagger market, and to explain how your score changes as you make or change forecasts and as questions resolve. We'll illustrate these cases with a few examples. Let's say I select a question, and I want to make a forecast. In this case, I want to change the current forecast probability of 2% to 4%. Before making the forecast, I have a current score of 1,160, which matches the available score because I haven't made any edits yet. When I make a forecast by changing the current value, I invest some of my available points to change the probability. And the system shows me the if true score and the if false score. Once accepted, I see my score changes. Now let's look at how and why these scores change this way. The Dagger scoring market is governed by Hansen's logarithmic market scoring rule. So when you make a new probability forecast, your score updates using the formula shown here, 100 times log base 2 of p prime divided by p. In this case, p prime is the new probability that you're entering for an event, and p is the old probability for the event. Now let's recall the previous example where we changed the probability that a question will resolve as true from 0.02 to 0.04. Initially, our expected score and balance were 1,160. Now if the question goes on to resolve as true, our score will change as the following. We used the previous formula that we introduced. 100 times log base 2 of 0.04, the new probability forecast, divided by 0.02, the old probability forecast, which gives a score change of positive 100. Similarly, if the question resolves as false, we can use the same formula to calculate our score change. Now in this case, by making that forecast, we're saying that the probability the question will resolve as false is now set to 0.96, whereas previously it was set to 0.98. So plugging these two numbers into the formula, we see a score change of negative 2.97. And then our balance changes by the minimum of these two scores. So in this case, negative 2.97 is less than 100. Therefore, a new balance is found by subtracting 2.97 from 1,160. And our score changes given an expectation. So in this case, we use the updated probabilities to multiply by the two different score changes to obtain our new expected score. One thing that you might have noticed about the scoring rule is that it gets a lot more expensive to push forecasts towards either 0 or 1. For this example, let's say that an initial forecast is sitting at the value of 0.5. If we want to push a forecast, say, to 0.99, we see that the blue line represents the score if the question resolves as true, so that's our potential gain. So we see that that increases, but we can compare that with the cost. That's the rewards if the question resolves as false. In this case, the value is negative. But we see that this value decreases a lot quicker than the blue line increases.